All right, thanks for joining me. We're going to talk about chapter 2.3, which is lines. We're going to develop equations of a given line given different types of information. Okay, I've got a couple different forms here of a line, or the equation of a line. I have standard form. Okay, and with standard form, you should notice that x and y are on the same side. So okay, so those two letters are on the same side. We also need to know that A, B, and C are integers, and A is positive. Okay, so x and y on the same side. X needs to be in this first term, and then y, and then your constant term is over here. We have slope-intercept, and the reason it's called slope-intercept is because I give you the slope, and I give you the y-intercept. Okay, and now this x here, this x and this y and this x and this y and even this y and this x, all three of those are the same. And the x, y's just represent any ordered pair that's on the line. So x, y are any ordered pair on the line. Are there any ordered pair that makes the equation true? Okay, this one we use a ton. So if you don't know it, then you definitely need to know it. So point slope form of a line, I give you the slope again, and I give you a point. Now this point is x1, y1, right here, x1, y1. And again, x, y are just the letters that we leave in there. They represent any ordered pair on the line. In 2.2, we talked about x and y intercepts, or where the line touches those axes. So to find the x-intercept, I plug in 0 for y because I want to know what x is. For the y-intercept, I'm going to do the opposite. I'm going to plug 0 in for x, and I'm going to look for what y is. And the slope is the rate of change or steepness of your line. So slope is m, and in algebra 1, you know, or from algebra 1, you know that slope is rise over run. Okay, which is great that you know that. That's not really how we want to look at it in college algebra. We want to look at it as the change of y over the change of x. Okay, the rise is how much my y values differ. Okay, if I just come over here, if I have this line right here, okay, and I want to know what's the slope from here to here, what's the slope of the line. I want to know how far do I go up, which is simply just finding how much does this y-axis change compared to how much do I change on the x-axis. And that's how we will find the slope. We'll look at the change. Now to find change, we'll take y1 minus y2 over x1 minus x2. Or we can flip those around. We can say y2 minus y1 over x2 minus x1. The thing that has to happen, though, is that these have to match up. If I start with y1, I need to start with x1. Likewise with the other way around. Okay, so determine the x and y intercepts. Okay, so if I want the x-intercept, to find that x-intercept, I'm going to let y be 0. So I want to know where is x when y is 0. Well, if I plug in 0 for y, this term right here goes away. And then how do I solve for x? I just divide by 2. So x is 5, 0. There's your x-intercept. To find your y-intercept, we'll plug in 0 for x and find out y. So this goes away. And I just divide by 4. So I have 0, 10 over 4 is the same as 5 halves, 5 over 2. I do not want a decimal, so don't give me a decimal. leave it in a fraction. Okay, so over here, x and y intercepts. For x, we want to know what x is, so we put 0 in for y. For the y-intercept, I want to know what y is, so we put 0 in for x. Okay, well, if I put 0 in for y, you notice there isn't a 0, so I still get just -2 for x. So there's your x-intercept. If we put 0 in for x, I get 0 equals -2. And we should know from past problems that if I get 0 equals -2 or some false value here, it's no solution. So in this case, there would not be a y-intercept in this case. And again, if there's no intercept, that means in this case we pass x at -2. And if I don't ever cross this line, I have a vertical line there. Okay. Now note that it crossed the x-axis and the only letter I gave you was x. This one has both letters and it's crossing both axes. So if I give you something like this, okay, I give you the y, so you should make the connection that that is only going to cross the y-axis. Determine the slope to classify the line. Okay, and when I mean classify, I mean, is it rising, falling, horizontal, vertical? What kind of line is it? Okay, so to find slope, we'll say change of y over change of x. And it's a good habit to get into writing that every single time. So if I look at change of y, that's 1 minus -3. Change of x, 1 minus -1. So that is 4 over 2, 2 over 1, and that is rising. Why is it rising? Because it has a positive slope. Okay, and I still wrote it 2 over 1 because I know I'm talking about slope. Slope is always a fraction. It is always the rate of your y over the rate of your x. How much change in both of those? So the next one, change of y, change of x. And remember, it doesn't matter the order. So I could go 1 minus 3, or I could go 3 minus 1. Let's go 3 minus 1. And the x is -3 minus, -3 minus 3. So I get 2 over -6, which is -1/3, and that is falling. Why is it falling? Because it has a negative negative sign out front. Change of y, change of x. So that's -2 minus -2, 3 minus -1. So that is 0 over 4, which is a slope of 0. Okay, so I'm rising none, and I'm going over 4. So if I have a line that starts here, and I don't go up any, but I go to the right 4, what kind of line is that? That would be a horizontal line. Okay, change of y, change of x. 3 minus -4, 1 minus 1. So that is 7 over 0, and 7 divided by 0 is undefined. So I have undefined slope. Again, if I have a point that starts, here, goes up 7, and doesn't go left or right any, what kind of line will I have? Vertical. So its slope is undefined. The classification is a vertical line. Write 2x minus 3y equals 15 in slope-intercept form, then graph. Okay, so we're going to take this. And slope-intercept form is the y equals mx plus b. So my goal here is to isolate this y value. So we're going to subtract 2x. -3y equals minus 2x plus 15. Divided by -3. So y equals 2/3 x minus 5. Okay. And this tells me two things. It tells me the slope, which is 2/3, and it tells me the y-intercept, which is -5. And we can refer to the y-intercept as -5, but when we write it, it would be 0, -5, and that's how we would write it. Find the equation of a line that has a slope of 2/3 and a y-intercept of 0, 1. Well, I give you the slope, and I give you the intercept. That should tell you that we need to use slope-intercept form. Well, the slope is 2/3, and the intercept is 1, and there's your equation. Now, often with something this easy, they'll say, what is it in standard form? Okay, so we'll take this, and we'll put it in standard form. So I need to move the x to the other side. So we'll subtract 2/3 x. So -2/3 x plus y equals 1. Remember, x and then y and then your constant. But this cannot be negative and it cannot be a fraction. So that's when we take it and multiply by my common denominator. So we'll have 2x minus 3y equals -3. And there is your standard form for the equation. Find the equation of a line that has a slope of -1/2 and passes through the point -1, 2. So there's two ways to do this one. Okay, so I have the slope and I have a point. So we can start with the slope or the point slope formula. Okay, so I have the slope, which is -1/2. I leave this x alone, and this one will be x1, y1. So I plug in minus -1, and then I have y minus 2. So then I just reduce it and get it y by itself. So I have y minus 2 equals, if I distribute that, this becomes a plus. So I have -1/2 x minus 1/2. I'll add 2 to both sides. So y equals -1/2 x plus 3/2. That's -1/2 plus 2 is 3/2. Now the second way we can do it is the way that I tend to do it, because I don't have to know this formula. Some of you might know that. It's just finding slope. But we all know y equals mx plus b. Do I know the slope? Sure. It's -1/2. Do I know an x and a y? Yes, x and y. What don't I know? I do not know my y-intercept. Okay, but can I take this equation and solve for it? Sure. So 2 equals -1/2 times -1 is 1/2 plus b minus 1/2 minus 1/2. 2 minus 1/2, we did that over here, is 3/2 equals b. So now that I have b and I have my slope, I'll say y equals -1/2 x plus 3/2. And we will notice that those two answers are identical. Doesn't matter to me which method you like to use or want to use. Just know that I would tend to go towards that method. Find the equation of a line that passes through the points -2, -1, and 3, 2. So this is a very good problem for a quiz or a test. Maybe I'll put fractions in here or something like that. So the first thing I need to do is find the slope. That's the change of y over the change of x. So we'll have 2 minus -1, 3 minus -2. So that is 3/5. Okay, so remember, I'm trying to figure out mx plus b. So I have the slope. Now I need to find the b value. So do I have an x and a y? Sure, I've got 2 of them actually. Does it matter which one I use? No. So go with the easier one. I'm going to use this one right here. So 2 equals 3/5 times 3 plus b. So 2 equals 9/5 plus b. I subtract 9/5. 2 becomes 10/5. 10/5 minus 9/5 is 1/5 equals b. So then we'll say y equals 3/5 from my slope, x, plus 1/5 from my b. And there's our equation. Again, they could say, what is this in standard form? And then you would just have to get x and y on the same side, get rid of all of your fractions. Find the equation of the following lines given their slope and a point that passes through that line. So here's our slopes, and then here's the point it crosses. We said earlier that if I have an undefined slope, that is a vertical line, and the vertical line has to cross your x-axis. Okay? Well, where is it going to cross this x-axis is exactly on the x that I gave you here. So we'll say x is minus 3. If we have a slope of 0, we said that that was a horizontal line, and the horizontal line has to cross the y-axis. Well, where is it going to cross? It's going to cross wherever this ordered pair is on the y. So we have y equals 5. Note that these didn't cross, like this one did not cross the y-axis, so there's not a y in the equation. This one didn't cross the x-axis, so there's no x in your equation. Okay, two lines are parallel if and only if their slopes are the same. Two lines are perpendicular if and only if their slopes are negative reciprocal. So this right here, and I looked it up here on Webster's dictionary, if and only if and only if, two figures are congruent if and only if one can be placed over the other. So that's an actual word. I didn't misspell it like normally I do. So it's spelt this way, but it's read if and only if. So these are two really important definitions here. So if two lines are parallel, their slopes are the same. So if I have this line, and this has a 1/3 slope, this one has to have a 1/3 slope as well to make them parallel. Perpendicular lines intersect to form a 90-degree angle. Well, negative reciprocals, if the slope of this one is 2/3, the negative reciprocal would be flipping this one over and changing the sign. So this would be -3 halves. Okay. Likewise, going the other way. If I give you this one, the negative reciprocal of this is positive 2/3. Determine if the lines are parallel. Well, we just said that if they are parallel, they have to have the same slope. Well, the slope of this one is 1/3. That x shouldn't be in the slope. Is 1/3. Okay. Well, I can't just look at this and find the slope. I'm going to have to solve it for y. So I'll add x plus x. 3y equals x minus 3. Divide by 3. Everything, you get y equals 1/3 x minus 1. So the slope of this one is also 1/3, making them parallel. So yes, they are parallel because they have the same slope. Find the equation of a line that passes through the point 1, 1 and is parallel to the line. So here's another good test question. Okay, so it is parallel to this line. Meaning if I have a new line that is parallel to this one, it will have the same slope. Okay. Well, the slope is 3. So I've got this new equation that starts off like that. Now, I do not know if this b value is the same. It could cross the y-axis somewhere totally different, so we'll put a b there. Now, do I have an x and a y? Sure, right here. So I'll plug that in, and I'll solve it. So 1 equals 3 plus b. Subtract your 3 from both sides, and you get minus 2. So your equation is y equals 3x minus 2. So they are the same steepness, but one crosses here and one crosses here. So up 3, 1, 2, 3, right 1. So this line's going here, and this line will be the same slope, just above it a little bit. Find the equation of the line that passes through the point 3, 0 and is perpendicular to the line 3x plus 1. So again, another good question here. It is perpendicular to this line, meaning my new slope is the negative reciprocal of this one. So the negative reciprocal of 3 is 1/3. So now I can get rid of that. So I have a point and a slope. So I have y equals negative 1/3 x plus b. So I'll plug in my x and my y. So I get 0 equals negative 1/3 times 3 plus b. So I have 0 equals negative 1 plus b. Add 1. B equals 1. So then my equation is y equals negative 1/3 x plus 1. So you will notice in this case, they had the same b value or the same y-intercept. What does that tell me about my picture? Well, that tells me that on the y-axis at 1 is where these two lines are intersecting. So I might have a line that looks like this, and then I'll have one perpendicular like this, makes it 90 degrees right there, but they intersect at that point 0, 1. So we have word problems with this. The average age that a person first marries has been increasing over the last several decades. In 1970, the age was 20. In 1990, it was 25 years old, and in 2010, it was 30 years old at the time of the person's first marriage. Find the slope of the line passing through these points. Describe what the slope represents. So I can make a graph out of this. Okay, but we might let that the x-axis here be years, and we'll let the y-axis be age. So I can plot these on here. So we'll plot this one at 1970 and 30. And we'll plot this one, and we'll skip to the last one here at 2010 and sorry, I had this is 20, this is 30. I want to know what's the slope of this line. Well, find slope, that's change of y over change of x. Well, how much does my y values change from 20 to 30? That's 10. And then my x-axis changes from 1970 to 2010. That's 40. So my slope is 1/4. But what does that mean? What is this 1/4 telling me? Well, that means 1 represents the age of marriage. And the 4 represents how many years of change. So every 4 years, the average age of marriage goes up 1 year. That's what it means. For every 4 calendar years, the average marriage age goes up 1 year. Suppose your two neighbors both use the same electrician. One neighbor had a 2-hour job that cost him $100. The other neighbor had a 3-hour job that cost him $130. Assuming that a linear equation governs the service charge of this electrician, what will your cost be for a 5-hour job? So again, we have a graph here. We've got 2 hours, $100, and we have 3 hours, $130. And so here and here. And I want to know what's the equation for this electrician. Well, I first need to find the slope. The slope is change of y over change of x. How much did I change in the y direction? It would be $30. How much did I change in the x direction? It was 1. So what does this slope tell me? It means this electrician cost me $30 per hour. But if we look here, $30 per hour for 2 hours is not $100. He's got a flat rate that he charges. So if I look for the equation, I have y equals 30 over 1x plus b. And I need to figure out what is this flat rate that he is charging people. Okay, so I'll take an x and a y. It doesn't matter which point over here I use. I'll use this one. So 100 equals 30 times 2 plus b. It's 100 minus or equals 60 plus b. Subtract 60. So 40 equals b. So my equation is y equals 30x plus 40. So the electrician is charging you just for showing up to your house or just talking to you. He's going to charge you $40. Then on top of that, he's going to charge you $30 for every hour that he's there working. But it says how much for a 5-hour job. So we'll say 30 times 5 plus 40. 30 times 5 is 150 plus 40 is $190. Okay, so he's going to charge you $190 for that 5-hour job. All right, here are your suggested problems on page 216. Again, here are your challenge problems. These are easy. They're true, false, and just a one-word answer problem. They might just show up on the true, false section on your test. As always, thanks for watching. This is at THS Mr. Jones signing off.